Hello everyone. We have started with tracing Cartesian curves, and yes, we have already taken two examples based on this. My next example here is tracing this curve y square into a square minus x square. This is equal to a cube into x, right? Now, let's see what is the symmetry, right? When you observe the power of x is even here, odd here, so I cannot use x term here, right? Now go to power of y. Power of y is even throughout, so that means this should be symmetric about x-axis, correct? The next thing is we are going to verify whether origin lies on this or not. So for that, just substitute x is equal to 0, y equal to 0 in the given equation. Yes, I'm getting 0 back, so that means yeah, absolute constant is not present, so it passes through origin, right? Then next thing, since I got origin as a 1 point on the curve, straight away find out tangent at origin. Tangent at origin, to figure out that, this is my equation. You need lowest degree term. Here the degree is 2, here the degree is 4, here the degree is 1. So lowest degree term is a cube into x. Put that equal to 0. So I have x is equal to 0. X is equal to 0 meaning y-axis is tangent at origin, right? Y-axis is tangent at origin, right? Now once you get tangent at origin, try to figure out intersection with coordinate axis, right? The first thing I'm going to figure out here, intersection with x-axis. To find out intersection with x-axis, you need to substitute y equal to 0 in the given equation. Now when you substitute y equal to 0, this side becomes 0. What remains? A cube into x is 0. This implies x is also 0, right? So when y is 0, x is 0. So what is the point? 0, 0 is the point of intersection. Is the point of intersection. Right? Then with the coordinate axis y, we need to figure out the intersection with y-axis. So substitute x is equal to 0. This is 0. This is 0. What remains? Y square into a is equal to 0. So y is 0. So again just 0 comma 0 point, right? So 0 comma 0 is the point of intersection. Though I got 0 comma 0 as a point of intersection, note that here I am getting at 0 comma 0 only single tangent, and which is y-axis. So since it is a single tangent at 0 comma 0, no cusp or no node, right, in the given curve, right? If tangent is double at that point, then at that case we are going to differentiate it in between cusp and node. But since single tangent at a common point, so yeah, just simply a curve, right, which touches the y-axis at a point 0 comma 0, right? So let's consider the next one. The next one is you need to find out asymptote, right? How to figure out asymptote? To find out asymptote parallel to x-axis, what you do, you consider highest degree term of x and you consider coefficient of that, right? So the highest degree term coefficient is here minus y square. Take minus y square equal to 0. So y equal to 0 is a asymptote parallel to x-axis, right? And yeah, that is x-axis itself, right? So one asymptote got from here. Let's go to y-axis asymptote, right? That is parallel to y-axis. To get this, you need to substitute the highest degree term of y coefficient equal to 0. Highest degree term y in the given equation is, here is the equation, y square, a square minus x square. Y square is the highest term, power term. So just substitute this equal to 0, right? So coefficient of highest degree term in y. This is e square minus x square, right? Take e square minus x square is equal to 0. So what is x? X is plus or minus e, right? So you got two asymptotes here. That is x is equal to a and x is equal to minus a, right? So area is clearly bounded by x equal to a and x is equal to minus a line. You need to decide the region, but yeah, the area is like this, right? Now let's decide what is the region of absence here. Correct. Now note that the first point to be noted is when x is, yeah, it is negative, yeah, there is no much difference in the denominator, but yes, because of x becoming negative, the whole term becomes negative and it results in y square negative, so that y becomes imaginary, so this is not possible, right? So one region I'm going to skip is when x is equal to, when x is less than 0, y square is less than 0. In that case, y is imaginary. So omit that part. The second condition is, now in the denominator subtraction sign is there. So that means when I consider x square to be greater than a square, so in that case this become negative, which results in the whole term negative. Again y square become negative, and so y is again imaginary, right? Let's simplify the condition little bit so that we'll get a clear idea what is the region of absence, right? So what I mean by here, x square is greater than a square, so this implies x must be greater than or equal to plus or minus a. So what is it? X must be greater than a and x must be greater than minus a. So what is the region to skip here? Let's try to draw it. Right? Now what is the region? I got these two things, that is, this is x is equal to a minus a, and this is x is equal to plus a and minus a, correct? And yeah, what do I have here? When x is less than 0, yes, this becomes imaginary, so it should not exist, right? And when x is greater than minus a, in this part, let's find out the common part where it does not exist. X is less than 0 and the other condition is x is greater than minus a. X is greater than minus a, that means here this is the region, right? So in this region, combining these two conditions, in this region mainly it does not exist, right? It may exist in the part, correct? Then what is the second thing? Second thing is when x is greater than a, it does not exist. So when x is greater than a, it does not exist. So this is the region of absence. This is the one region and this is the other one. I'm just combining these two conditions together, and this region satisfies the condition, so that's why I'm not going to draw any part of the curve in the particular region. Okay, then what else we got here? That is y-axis is tangent at origin. So y-axis, this is a tangent at origin, so the curve must be like this, right? But what else we know here? That is y-axis is x-axis is asymptote And what else I know from here is these two lines are asymptote, which are parallel to y-axis. So this is also asymptote, y equal to 0. This is also asymptote, x is equal to minus a, and this is also asymptote, x is equal to plus a, right? So since this is a asymptote, the curve should touch my origin, so it should touch the origin, so it should draw like this. It is touching the origin, and since this is asymptote, so that means at infinity the curve will touch the line, but not immediately, so I need to continue like this. And similarly here also I need to continue like this, right, since this is a asymptote, correct? This is the point, so I need to continue like this. Similarly this is also asymptote. I cannot draw here anything. This line is also asymptote, x-axis is also asymptote. That means my curve should be like this. Similarly it is symmetric, so draw in the negative part as well. So curve should be like this. So the combination of these two is nothing but my given curve. Okay, please note the main portion here. Okay, and that's it.